Welcome to Night Chemistry, your midnight laboratory of calm. Draw the curtains of your mind, let the room dim to twilight blue, and invite a single measured breath together. Inhale to the count of 4. 1, 2, 3, 4. Hold weightless, expectant. 1, 2, 3, 4. Exhale for 6. 1, 2, 3, 4, 5, 6. Feel tension ebb like a low tide that leaves quiet pools of stillness behind. Now picture the soft glow of a distant dawn washing over a silver-gray shoreline strewn with pale, feather-light rocks. Those stones carry lithium, the lightest metal in creation, so buoyant it can float on water, so bright it flares rose-red in a candle flame. In your palm, imagine a single flake shimmering like frost on a leaf, silky, almost weightless. Yet inside it hums a restless energy that one day will steady racing hearts and hush runaway thoughts. As you breathe, let the scene widen until the periodic table drifts into view, its rectangles gleaming like stained glass panes in a night-lit cathedral. Your gaze settles on the third square, upper left, just beneath helium, marked with a quiet crimson glow, Li. 2 paired electrons orbit close to the nucleus. A lone outer electron lingers farther out, eager to wander, ready to trade places, to move. That single traveler is why lithium slips so easily into batteries, into neurons, into cells seeking balance. Take another gentle breath. Inhale the subtle brightness of lithium. 1, 2, 3, 4. Hold, as though that tiny wandering electron pauses inside your chest. 1, 2, 3, 4. Exhale, and feel thoughts find a steadier rhythm. 1, 2, 3, 4, 5, 6. Shoulders soften, jaw unclenches. Muscles release small storms you did not know they carried. Float here a moment longer, poised between shoreline dawn and star-mapped night, buoyed by the metal that lifts mood and lights 1,000 million phones. When you are ready, let consciousness rest on that glowingly bright, patient, and quietly powerful, knowing our deeper journey into the mood metal is about to begin. Discovery 1.1. Who first revealed lithium? Let night gather around you like quarry dust settling after a long day's hammering. The year is 1817, and on the wooded island of Uto in Sweden, miners pry open a pale, glassy mineral called petalite. They cart chunks of it to Stockholm, where a young aristocrat chemist, Johann August Arfwedson, has taken up residence in the laboratory of the celebrated Jöns Jacob Berzelius. Picture rows of stoppered bottles, pewter balances shimmering in candle glow, and a window cracked open to the Baltic wind. Arfwedson grinds petalite and dissolves the powder in aqua regia. He titrates the filtrate against sulfuric acid, expecting the ledger of weights and measures to close elegantly, yet his sums refuse to balance. Something impossibly light lingers in the residue, lighter than sodium, lighter than potassium, its presence betrayed only by decimals that drift like mist across the page. Berzelius leans in, brow furrowed, and agrees. The arithmetic hints at a brand new element. They tip a bead of the unknown salt into a blowpipe flame. Whoosh! A carmine rose flare erupts. No terrestrial element burns quite so vividly. In that flicker, lithium steps from stone into story. Across the channel, chemist William Brandy receives the Swedish report. By 1821 he has duplicated the analysis, electrolyzing a molten lithium oxide crust until silver pinpoints of metal form at the cathode. Tiny, soft globules that skitter across water before erupting in crimson fire. London newspapers marvel at a metal half the weight of water, which nevertheless blazes like pyrotechnic silk. From mine shaft to metropolis, lithium's introduction is brief, bright, unforgettable. Much like the mood it will one day steady. Slow your breath now. 4 counts in, hold 4, release 6. Imagining that rose-red spark blooming in the dark, then cooling to a gentle ember behind closed lids. 1.2. When the element emerged from silence. 4 decades lithium remained an academic curiosity, prepared only in milligram flecks by devoted chemists. But curiosity gathers allies. In 1855, physicist Robert Bunsen and physician-chemist Gustav Matheson assemble a colossal battery of 90 series-connected cells at Heidelberg. They channel 700 amperes through molten lithium chloride, and for the first time kilograms of the ghostly metal appear, silvery ribbons that quiver in moist air, then tarnish to dove gray. Railways adopt lithium salts for crimson signal lamps. Pyrotechnicians grind it into firework stars. Pharmacists compound lithium citrate for gout and kidney stones. Yet lithium's most profound rendezvous with humanity waits until 1949, when Australian psychiatrist John Cade administers lithium carbonate to manic patients at Melbourne Mental Hospital. Their racing thoughts decelerate. Sleep returns, tempers soften. Within a decade, controlled trials across 6 countries confirm the effect, and lithium earns its quietly heroic title, the mood metal. Think of a pendulum slowing. With each breath, feel emotions that once swung in wide arcs settling toward center. Inhale, hold, exhale, and sense the calm weight lithium will one day lend to restless minds. 1.3 Conditions and circumstances of discovery. Return to Berzelius's workshop. Floorboards dusted with feldspar, retorts blackened by charcoal flames, and a young Arfwedson hunching over a platinum crucible the size of a walnut. Glass funnels drip pale filtrate into beakers. Every few minutes a quill scratches figures onto parchment. These are the waning days of early analytical chemistry. No spectrometers, no electrical balances, only keen eyesight, flame color, and arithmetic. That Arfwedson discerns a new atom among such primitive tools testifies to both precision and patience. Shift scenes to Heidelberg 3 decades later. Bunsen's lab smells of ozone and hot brine. Thick copper wires lead from his battery to a glowing clay crucible. Sparks crackle, and vapor of chlorine slithers up the chimney. When the reaction subsides, Matheson cracks open the crust and grasps a lustrous ingot lighter than pine wood. They submerge it in kerosene, wrap it in oilcloth, and dispatch samples to colleagues across Europe. Within a year, textbooks rank lithium beside sodium and potassium, the last step in the alkali staircase. Finally, enter the post-war psychiatric ward of 1949. Fluorescent lights hum overhead. Patients pace tiled corridors. Dr. Cade, wary of earlier scandals with bromides and barbiturates, stirs lithium salts into fruit juice in microdoses. To everyone's astonishment, the raging voices subside, the need for restraints fades, and conversations turn to families and future plans. Lithium's lone 2's electron, so eager to travel, has found passageways in neural circuitry, modulating serotonin, dampening glutamate storms, and coaxing gray matter to regrow where stress once eroded it. Let that image nestle in thought. A single traveling electron delivering peace. Breathe in steady rhythm. 1, 2, 3, 4. Hold. 1, 2, 3, 4. Exhale. 1, 2, 3, 4, 5, 6. And picture neurons glowing soft rose, as calm and constant as lithium's flame. The crimson flare has faded. The element's path from quarry rock to quiet mind now glows behind your eyelids like an afterimage. Rest a moment in that glow, knowing our journey will next explore lithium's surprising powers and gentle presence throughout planet and cosmos. Properties and presence. 2.1 Key physical and chemical properties. Imagine balancing a silver feather on your palm. Cool, soft, and so light it seems to hover. That is lithium. Density 0.534 gcm superscript 3. Less than half that of water. A fresh slice shines like polished chrome, but within heartbeats it blushes dove gray as it steals oxygen and nitrogen straight from the air. Tap it with a fingernail and you leave a crescent dent. Drop it in a beaker and it skitters, hissing, atop the surface before bursting into carmine flame that perfumes the room with almond bitterness of hydrogen and LiOH mist. Its melting point, 180 degrees Celsius, arrives sooner than a kitchen sugar caramel. At 1342 degrees Celsius it boils, spraying sparks the color of raspberry sherbet. Yet what makes lithium truly restless is its single twos electron, loosely held, eager to wander. That lone traveler gives the metal the highest electrochemical potential of all elements, almost 4 volts per atom when shuttled between graphite and cobalt oxide in a battery. Add the tiniest push and Lie darts into crystal lattices, slipping through grain boundaries others cannot enter, hydrating so strongly that aqueous ions drag 5 water molecules along like a cloak. Under fierce pressures, lithium astonishes theorists. It becomes a narrow-gap semiconductor, then a superconductor, then adopts crystal structures never seen in nature. At cryogenic temperatures, eutectic alloys of lithium and calcium levitate magnets, hinting at future quantum machines. Breathe in for 4 counts, imagining that lone electron circling the nucleus like a firefly in dusk. Hold 1, 3, 4. Then exhale for 6, picturing it blazing crimson as it leaps away, leaving calm silver behind. 2.2 Position in the periodic table. Lift your gaze to the periodic stained glass window. Top left quadrant shines a small ruby tile. Li atomic number 3. Perched beneath helium on period 2 and crowning the alkali metal column. Yet lithium is an unconventional monarch. Its tiny ionic radius polarizes neighboring clouds of electrons, lending compounds a surprising covalent flavor unknown to heavier cousins like potassium. This polarizing power explains why lithium carbonate is sparingly soluble while sodium carbonate pours like sugar. Chemists speak of a diagonal relationship. Lithium resembles magnesium more than rubidium, forming a stable nitride directly from air, a trick no other alkali attempts. Picture the table as a mountain path. Hydrogen springs from the valley as an eager river. Helium crowns the first ridge in serene isolation, and lithium marks the place where landscape tilts from ethereal gas to solid ground. One step to the right and the world fills with neon signs and diamond lattices. One step down and the alkali cascade begins. Metals growing heavier, softer, more explosive, echoing lithium's lone electron temperament but never matching its featherweight grace. Let the next breath trace that path. Inhale up the slope from hydrogen square, pause on lithium's crimson promontory, then exhale down toward neon lights and mineral plains, carrying inside you the quiet certainty of element 3. 2.3 Prevalence and natural sources. Now widen your vision. Out among the first minutes of the Big Bang, only wisps of lithium-7 formed in the plasma torrent. So little that cosmologists still puzzle over why some ancient stars shine richer than theory allows. Stellar cores consume lithium like firewood, so to replenish the element the universe relies on rarer dramas. Cosmic ray impacts that shatter carbon into Li-6 and Li-7, red giant convulsions that dredge up fresh lithium in final luminous flares, nova outbursts that seed interstellar clouds with dusty grains containing a scant teaspoon here, a thimble there. Relative to hydrogen, lithium is a ghost, about 1 part in a billion. And yet every smartphone, every pacemaker, every Mars rover now depends on that ghostly trickle. Return to Earth. Only 20 parts per million hide in crustal rock, but geologic alchemy concentrates lithium where granite pegmatites cooled slowly eons ago. In Australia's Greenbushes belt, milky white spodumene crystals thicker than a child's leg criss-cross quarry walls like frozen lightning. Across the Pacific, the Andean salas, Uni, Atacama, Hombre Muerto, shine turquoise under thin desert sky. Shallow brines ripple over ancient volcanic fissures, stewing lithium chloride in sun-powered ponds until it reaches battery-grade strength. Under the plains of Arkansas and Alberta, oil-field brines carry dissolved lithium each time an old well gurgles to the surface. Engineers now skim ions with ceramic membranes, turning wastewater into future cathodes. Even oceans cradle the metal, 0.18 ppm, enough that every wave cradles a whisper of Lee. Rivers deliver more each season as rain scours granites. Hydrothermal vents gift smoldering plumes at the mid-Atlantic ridge. Tiny organisms swap sodium for lithium in cell membranes, cycling trace amounts through food webs until they wash back to sea. You sip perhaps 200 micrograms daily without knowing. A benign stowaway in coffee, spinach, spring water. Epidemiologists quietly note that regions with slightly higher natural lithium in drinking water record lower rates of depression and suicide. Another hint of lithium's gentle stewardship over mood. Pause for one last measured breath. Inhale and picture pale rose salt flats shimmering under a noon sun. Li ions aligning inside liquid crystals ready for harvest. Hold, sensing their featherweight promise. Exhale, watching them drift. Into batteries, into synapses, into deep space probes riding solar winds past Neptune. Element 3 is sparse yet ever-present, evasive yet essential, hiding in stone but reaching your heartbeat each day. Rest a moment in that paradox. Something almost absent from the cosmos, yet powerful enough to steady human minds and power our brightest tools. Let muscles relax into that lightness before we journey onward to lithium's cosmic rolls and healing whispers. Role in the universe. Lanterns that fade. Stellar lifetimes written in lithium. Imagine the sky just after sunset. Still blue where the sun has slipped below, but already seeded with the first faint stars. Somewhere out there, astronomers peer through spectrographs the size of pianos and trace a single razor-thin absorption line at 670.8 nanometers. lithium's quiet signature. In newborn stars that line glows clearly. Yet as decades of fusion stretch into millions of years, the line fades, erased by roaring convection that drags lithium atoms down to seething interiors where temperatures exceed 2.5 million K. Because lithium is so quickly consumed, its strength on a stellar spectrum becomes a cosmic clock. A T-Towery infant flares with 10 times the sun's lithium. A middle-aged sun-like star shows barely a whisper. A swollen red giant may carry none at all. So astronomers talk of lithium depletion ages, dating clusters the way dendrochronologists count tree rings. Breathe in slowly when 3, 4. Imagine those stellar clocks ticking thousands of years per heartbeat. Hold 3, 4. Then exhale 5, 6, letting time itself drift outward into the night. Yet there are rebels. Roughly one red giant in 20 suddenly brightens with fresh lithium, as though digging up buried treasure. Astronomers call them Lie-rich giants. A brief convulsion dredges fusion ash to the surface, lighting the spectrum with an unexpected crimson stripe. The event lasts mere millennia, an eye blink in stellar life, but proves that even dying stars can mint new lithium just before they dim forever. The cosmic lithium problem, a riddle of birth and destruction. Shift perspective far beyond any single star, to the first 3 minutes after the Big Bang. In that white-hot plasma, neutrons and protons slam together to form hydrogen, helium, and a trickle of lithium, 7. Roughly one nucleus for every 10 billion hydrogen atoms. Physics models predict that ratio with exquisite precision. Yet when we measure the oldest, most pristine stars, we find triple the lithium theory allows. The universe either makes extra lithium somewhere, or destroys less than we think. Part of the answer arrives in fireworks. When a white dwarf siphons gas from a companion until runaway fusion ignites, a classical nova can fling a cloud rich in freshly forged lithium into interstellar space. Radio telescopes in 2020 captured spectral fingerprints of lithium, 7 streaming from nova V1369 Centauri, an observation equal parts triumph and puzzle piece. Now, with each nova catalog, the inventory grows. Lithium isn't just a Big Bang leftover. It's still being minted in fiery redistributions of stellar debt. Then there are cosmic rays, protons and alpha particles hurled at nearly light speed by supernova shocks. When they collide with interstellar carbon or oxygen nuclei, the heavier atom shatters, and lithium spalls off like bright ember fragments. This high-energy hailstorm sprinkles Li-6 and Li-7 through molecular clouds that will one day coalesce into solar systems. Inhale again, picturing invisible sparks ricocheting through cold dust. Hold as they carve fresh atoms from ancient grains. Exhale, letting the silence of space settle around that vision. Even with novae and cosmic rays accounted for, the tally still wobbles, and the cosmic lithium problem remains open. Perhaps dark matter interactions tweak early universe chemistry. Perhaps stellar atmospheres hide more lithium than we can yet measure. The missing pieces hover like half-remembered dreams. Close, alluring, not quite caught. From stardust to synapse, the element's long journey home. Picture a sun-like star nearing its quiet end. A final pulse of helium fusion coughs lithium-rich gas into a planetary nebula, a translucent shell glowing marigold and teal. Over tens of millennia, that shell diffuses, mixing with neighboring clouds until a denser knot collapses into a new protostar, dragging inherited lithium into its disk. In that swirling nursery, dust grains coated with water ice and organic tar gather lithium atoms the way dew gathers dawn light. Millions of years pass. Pebbles become boulders. Boulders merge into protoplanets. Some lithium locks into the crust of a rocky world, hiding in pegmatite seams. Some dissolves in young oceans, waiting for river cycles to guide it to Sala flats. Billions of years later, intelligent life discovers it, first as a flickerose flame test, later as a steadying hand for turbulent minds, and finally as ions shuttling between graphite sheets to light midnight screens. Take one last measured breath. Inhale, sensing the vast loop from nova flash to human thought. Pause, 1, 2, 3, 4. Then exhale, picturing lithium ions gliding through both star-forged nebulae and the slender axons of your brain. Element 3 has crossed gulfs of time and vacuum to arrive here. In this quiet room, in this calm moment. Let that realization settle in your chest. An ember of cosmic history, glowing softly as you drift toward deeper rest. Role in life. 4.1. Gentle currents in blood and brain. Bring awareness to the quiet pulse behind your collarbone. With each beat, a river of plasma, roughly 5 liters, flows through arteries and capillaries, and in every milliliter glide a handful of Li ions. Tiny, almost weightless, they replace sodium here and there, nudging water balance, whispering along neural conduits. The entire store in an adult body weighs less than a single grain of rice, yet its influence is symphonic. Slip back to 1949 Melbourne. Psychiatrist John Cade stirs lithium carbonate into lemonade for a patient caught in manic tempest. Within days, the racing monologue softens. Within weeks, restful sleep returns. Modern imaging now reveals why. Lithium slips through sodium channels and settles near glycogen synthase, kinase 3, an enzyme that otherwise fuels runaway signaling. The ion's presence calms that enzyme, lengthens circadian rhythms, boosts BDNF, a growth factor that coaxes new neurons to bloom in the hippocampus like spring shoots after drought. Picture synapses as tiny harbors lit by lanterns. Before lithium, storm waves batter the docks. Lanterns flicker. After lithium, tides steady, piers mend. Orange light glows steadily over calm water. Breath in for 4 counts, feeling that steadiness fill the chest. Hold 1, 2, 3, 4. Then exhale for 6, letting turbulent thoughts ebb into quieter pools. Beyond psychiatry, lithium salts ease cluster headaches, shorten bipolar depressive episodes, and may slow amyloid tangles linked to Alzheimer's. Ongoing microdose trials explore whether a few micrograms in daily spring water can lift clouded moods on a population scale. Epidemiologists chart maps where groundwater holds a breath more Li. Those counties often show lower suicide and dementia rates, a soft statistical hum hinting at biology's secret gardener. 4.2. Earthly pathways and subtle ecologies is almost equal to 400 words. Shift attention outward to a high Andean sala at dawn. Shallow brine pools glow rose and gold. Here lithium begins a long pilgrimage. Rain leaches it from granite peaks, rivers deliver it to closed basins, sun concentrates it until brine workers skim liquid crystal into troughs. Months later tanker ships carry pale green lithium carbonate across oceans. In spotless factories ions will soon shuttle between graphite and cobalt oxide, ready to light midnight screens and balance power grids at dusk. But lithium's cycle intertwines with life long before industry. Upstream, halophytic plants sip brackish water, storing Li in leaves that llamas graze. Trace amounts travel into wool, into soil again, back to rivers, always circulating, rarely resting. In coastal wetlands, certain diatoms weave lithium into silica shells, adjusting buoyancy. When tides recede, their ghostly frustules litter mud flats like microscopic lantern glass. Follow a raindrop landing on a granite ridge in Norway. It seeps through feldspar, liberates Li, drips into moss, trickles to a trout stream, and months later evaporates from a leaf in a Danish beech forest, leaving an ion behind to wander root cells. Some of those ions eventually reach municipal taps. A college student drinks a glass before finals, never guessing how quietly the element steadies pre-exam jitters. Breath deep again. Inhale that image of unseen guardianship. Pause. Exhale, trusting unseen helpers at work within and around you. Even lake microbes sense lithium's presence. In lab flasks, cyanobacteria exposed to tiny Li doses alter pigment ratios, tuning photosynthesis to low-light mornings. A botanical hush button. Ecologists experiment with minute lithium additions to desert soils. Seedlings under stress grow thicker roots, as if consoled by an ancient mineral lullaby. Yet balance matters. Too much lithium in effluent can stress freshwater snails. Advanced battery recyclers now harvest spent cathodes, recovering 95% of lithium so rivers remain calm. Around solar salt ponds in Chile, engineers pump brine back once magnesium is skimmed, maintaining flamingo feeding grounds. The mood metal teaches stewardship, equilibrium in neurons, in wetlands, in industrial loops. Take one final breath for this chapter. Inhale, sensing ions glide through bloodstream and river alike. Hold, feeling stability spread from pulse to palm. Exhale, letting shoulders sink as gently as lithium-rich brine settles in its pool. The element's light touch steadies both mind and ecosystem, inviting you to rest in that same poised serenity before we explore the tools, greases, and glowing screens it empowers. Practical applications of helium. 5.1. Quiet power batteries that breathe light. Picture the soft glow of your phone as you set an alarm for morning. Beneath its glass sleeps a forest of graphite layers, each grove welcomingly ions like evening birds returning to roost. When dawn arrives and you lift the device, those ions flutter out toward a cobalt oxide hillside on the opposite electrode, releasing a measured trickle of electrons, enough to spill music into earbuds, guide a GPS arrow, or light an e-ink page for sunrise reading. Scale that chemistry 1,000-fold and you have an electric bus coasting through city fog. Whisper quiet except for tire hum. 10,000-fold and a grid-scale battery farm steadies wind turbine surges so hospital monitors never flicker. In Tesla-style cells, lithium's light, eager nature means 250 Wh per kilogram, 5 times the energy of lead acid batteries your grandparents used. New chemistries: lithium, iron phosphate, lithium, sulfur, lithium manganese rich. Trade tiny tweaks in crystal spacing for vast leaps in safety or cost. Engineers now weave solid-state electrolytes thin as rice paper. Ions glide through ceramic channels impossible for flammable liquids to penetrate. Imagine breathing through a forest where every path is stone-paved. No puddles, no sparks. That future pouch cell may power drones that pollinate orchards at dawn, exoskeletons that steady elderly knees at dusk, and pacemakers that tick for decades on a single charge. Take a slow breath now, 4 in. Feel an invisible current flow. Hold 1, 2, 3, 4. Then exhale, 6 out, imaginingly ions migrating home for a nightly recharge. 5.2. Metals that flow, greases that soothe, glass that glows. Slide into a jet engine overhaul bay. Mechanics smear lithium stearate grease onto turbine bearings. The thickener stays creamy from -60 degrees Celsius Arctic taxi to +200 degrees Celsius re-entry heat, never charring, never weeping. Far above, satellites spin on similar grease. Lithium atoms cushioning gyroscopes that guide weather forecasts and search and rescue beacons. Step next to a glass furnace where powdered lithium carbonate lowers silica's melting point by hundreds of degrees. The result? Oven-safe casserole dishes that shrug at thermal shock, telescope mirrors honeycombed for featherweight launch, and smartphone screens thin yet stubborn against pocket drops. Add lithium to porcelain and the glaze turns translucent moon white, prized in Asian teaware for holding candlelight like milk. In metallurgy labs, alloy masters stir slivers of lithium into aluminium, forming wings for next-generation electric aircraft. 1% lithium cuts density, stiffens ribs, and dampens vibrations, a feathering of mass that lets planes climb on fewer electrons. In nuclear plants, molten lithium lead blankets capture stray neutrons and breed tritium for future fusion, while tiny beads of Li-6 guard detectors that sniff for clandestine fissile material at cargo ports. Breathe in, inhale furnace glow turned gentle by lithium's touch. Hold, feel strength without weight. Exhale, let heat drain away like glass annealing to quiet transparency. 5.3. Future horizons, fusion, air and far-orbit dreams. Turn your mind to a tokamak the height of a cathedral. Inside, a plasma burns at 150 million degrees Celsius, hotter than the sun, and engineers spray lithium vapor onto the carbon walls. The metal plates them in a silvery film that grabs stray hydrogen, taming edge turbulence so fusion fire can roar steadier, longer. In Japan's JT60SA and Europe's ITER, this liquid metal cloak may soon coax the first net energy pulse from humankind's star jar. Shift to an arid plateau where direct air capture fans pull CO2 from sky. Rechargeable lithium sorbents swing between hungry for carbon and ready to release it under mild heat, bottling greenhouse gas for concrete or synthetic fuel. Each cycle is a breath. Lithium inhales trouble, exhales possibility. Now drift even higher. On NASA's Artemis missions, lithium, sulfur prototypes promise twice the energy per kilo of today's packs, granting lunar rovers week-long treks on a single night-side charge. CubeSats already loft lithium-ion thrusters that sip xenon ions from magnetized drums, trimming orbits with gram-level propellant budgets. Future interplanetary craft may sail on lithium plasma arc jets, the metal's low atomic mass turning electrical pulses into bright, efficient thrust. Take one final breath for this block. Inhale, picturing crimson sparks in Arfwedson's flame evolving into the silent blue glow of fusion plasma. Hold, sensing centuries collapse to a moment. Exhale, knowing every laptop key press, every midnight reading lamp, every pacified neuron owes something to the feather-light metal that refuses heaviness in body or spirit. Lithium works unseen. In grease that never melts, in glass that never shatters, in batteries that quietly cradle daydreams and night notes alike. Let that assurance settle over you like dawn-pink brine on a mirror lake. Rest easy. The mood metal stands ready in minds, in cells, in synapses. Ever light, ever steady, ever near. Curiosities and Mysteries. 6.1. Secret Talents and Everyday Surprises. Close your eyes and picture a silvery flake of lithium floating on a still pond. No other metal can do that trick. Every rival sinks. At first the flake drifts lazily, but then a fizz of hydrogen erupts from its edges as lithium trades its lone electron for a sip of water. The metal skitters like a leaf in sudden wind and bursts into a scarlet flame before disappearing with a soft pop. A laboratory party trick, yes, yet also proof that lithium's spirit is half air already. In the late 1920s, soda fountains in the American South served a cloudy citrus drink called bib label lithiated lemon lime soda. You know it today as 7-Up. Each bottle once held nearly 150 milligrams of lithium citrate, advertised to lift spirits during Prohibition gloom. Regulators pulled the mineral in 1948, but for nearly 2 decades moviegoers unknowingly sipped microdoses that modern psychiatrists would one day prescribe on purpose. Strike a match to a lithium salt, and the flame blazes a pink so intense that fireworks engineers call it dragon's breath. That same color helps forensic scientists. A quick lithium flame test tells whether brake fluid is counterfeit, because genuine glycol esters reveal no crimson tint. In remote border crossings, customs officers wave handheld burners over barrels. A single spark of rose and the shipment is flagged for deeper scans. Take a slow breath, 1, 2, 3, 4. Envision carmine sparks swirling upward. Hold, letting curiosity brighten behind your eyes. Exhale, 6 counts, sending any lingering tension away like embers fading into night. 6.2. Lingering mysteries and unfinished puzzles. Zoom out to the stars again. Astronomers still wrestle with the cosmic lithium problem. Why do ancient halo stars shine with 3 times more lithium than Big Bang Theory predicts? Some propose that dark matter particles collided with protons in the early universe, seasoning it with extra Li-7. Others suspect our stellar atmospheres fool us, hiding lithium in cooler surface layers like coins slipped beneath sofa cushions. Each new telescope, Gaia the James Webb, adds data, yet the ledger refuses to close. The lightest metal keeps its first secret. Closer to home lurks the missing lithium paradox inside Earth's crust. Radioactive decay in granite should have generated vast riverine plumes by now, but groundwater surveys come up shy. Geochemists wonder if lithium hides in deep mantle perovskites or in clay lattices that lock ions tighter than a bank vault. Drill cores from the Mariana Trench offer hints. Tiny lithium spikes in serpentinized rock, but no full accounting yet. Until someone sends boreholes deeper than ocean trenches, the tally will stay provisional. Breathe again, inhale the riddle, accept its open ending. Hold 1, 3, 4. Exhale, letting the puzzle rest unsolved for now. Some questions lull the mind precisely because they stay unanswered. 6.3. Footnotes, anecdotes, fireside tales. The coin in solar orbit. In 1972, Apollo engineers alloyed a batch of sunlight-shielding washers with 3% lithium. One washer slipped free during assembly, hitching a ride on the service module. When the crew jettisoned debris before re-entry, the tiny ring sailed into heliocentric orbit, becoming a silent 1-gram satellite of the Sun, lighter than a postage stamp, destined to circle our star for millennia. Soap bubble sparks. At a Royal Society banquet in 1879, prankish physicist William Crookes dissolved lithium stearate in ether and blew bubbles across the hall. Each iridescent globe glimmered crimson when it drifted into gas jet chandeliers, startling dignitaries and singeing a duchess's plume. The demonstration was meant to show how metal ions color fire. It instead proved how quickly Victorian hats could ignite. Tales from the track. Formula E pit crews paint torque wrenches with lithium grease-tinted fuchsia. The color warns mechanics that the grease is hygroscopic. Leave it uncapped too long and it will sip moisture, swelling from silky gel into useless froth. Rookie techs learn fast. By dawn, the magenta smear on floor tiles tells who forgot the lid. A rain in the clean room. In 2015, a semiconductor fab in Taiwan reported pink snow drifting inside a Class 10 clean bay. A microscopic lithium polymer had sublimated from a cracked battery prototype, nucleating tiny crystals that fluttered like sakura petals. No circuits were harmed, but engineers still keep a photo of the rosy flurry taped to the break room fridge, proof that even in hyper-controlled spaces lithium finds a way to surprise. A library of the mind. Ancient scrolls charred in the eruption of Vesuvius were long thought unreadable, their ink fused to black glassy ash. Recently, synchrotron X-rays tuned to lithium's absorption edge revealed faint scribbles in Greek philosophy under the crust. Scribes had mixed trace lithium salts into their soot-based ink, perhaps to deepen color. 2,000 years later, that quirk lets historians resurrect lost lines of Epicurus. Draw one final breath, gathering sparks, riddles, and wayward coins into a loose bundle of fascination. Hold them light in mental palms, then exhale, Let them drift upward like those lithium-laced soap bubbles, harmless and glowing, until they vanish into the dark. The mood metal has many stories, and it keeps a few tucked away for future dreamers. Allow that thought to settle, shoulders soft, eyelids heavy. Curiosities rest for now. You may rest alongside them. Elemental dreams and sleep descent. Let the lights dim behind your eyelids until only a rosy afterglow remains, soft as the crimson flare of lithium in a candle flame. Draw a deliberate breath, 1, 2, 3, 4. Feel it lift the front of the chest like a faint tide. Pause, 1, 2, 3, 4. Then let the air ease out, 1, 2, 3, 4, 5, 6, carrying any sharp edge of thought with it. Now imagine yourself standing at the edge of a vast sala under pre-dawn sky. Shallow pools stretch to the horizon, their surfaces so glass, still they mirror the Milky Way in perfect symmetry. Tiny ripples of brine trace pale rose spirals around your ankles. Within those ripples drift countlessly ions, light as snowflakes, unhurried as moonset. Each ion has traveled eons, from nova fire to nebula dust to granite crest and river vein, finally reaching this tranquil basin just to wait, shimmering for morning sun. Feel the ground beneath you grow lighter, as though gravity has turned down its dial. With every slow inhale, sense electrons slipping from your shoulders, unburdening muscles that labored all day. With every exhale, picture crimson sparks fading into cool ash, leaving the mind a quiet plain where breezes roam without stirring dust. High above, the first heliacal glow paints the Andes lavender. The brine pools pick up that hue and bloom into a watercolor gradient, lilac, coral, peach. As colors deepen, trace a path across the flats. Solar-powered pumps ferry brine into terraced ponds, where sunlight will coax lithium chloride into crystalline memory. Later, those crystals will ride rail cars toward distant coasts, melt into cathodes, and one day keep a traveler's e-reader aglow on another sleepless night. But for now, all is still. Ions rest, you rest. Let awareness drift upward, toward a silent balloon floating on dawn thermals. Its thin aluminium frame carries a sensor cradled in lithium stearate grease, smooth, unwavering, logging ozone data that will guard farmers and fishermen later in the week. The balloon rises effortlessly because helium inherits lightness, but its instruments endure the cold because lithium grants resilience. Notice how cooperation rules the sky. Elements sharing gifts, energies balancing. Turn gently inward again. Picture your own neurons as lantern-lit piers along a moonlit canal. Lithium ions glide there, steadying water levels, taming errant waves. See synaptic lanterns glow a soft rose, reflections rippling across calm cognitive waters. If stray worries surface, deadlines, arguments, unsent emails, place them on a tiny lithium glass skiff and watch it drift toward the horizon until even the lantern light dissolves into morning haze. Breathe once more, slow in, softer out, and feel the small, precise weight of your heart settle into rhythm. That rhythm, like lithium, is humble yet steadfast. A single beat repeated 50 million times a year, a single outer electron ready to roam, returning serenity to each cell it meets. Tonight the element stands watch, gentle custodian of balance, in circuitry, in ecosystems, in the vaulted chambers of the mind. Whatever hours remain before sunrise belong to rest. Muscles sink deeper into mattress. Pulse hums at a quieter metronome. Thoughts thin to whispers, then to wind, then to open space. Let the sala fade, leaving only cool air, starlight, and the hush of element 3 cradling your dreams. In this moment nothing is urgent. The mood metal steadies the world. You need only breathe. 1, 2, 3, 4. Pause. 1, 2, 3, 4. Release. 1, 2, 3, 4, 5, 6. Drift on that cadence. Drift until the rosy horizon of sleep meets morning's first pale blue, and you wake lighter, balanced, and quietly bright. Now, as our journey softly comes to a close, allow yourself a moment of quiet reflection. Feel how each calm breath gently connects you to the element we've explored tonight, one tiny piece in the infinite mosaic of the universe. As you drift gently toward rest, picture your thoughts like atoms of the element we've visited today, floating serenely through the vastness of your imagination. Just as elements combine, transform, and quietly support all life around us, your mind now settles, combining peace with tranquility. Remember how every atom within you once journeyed through stars, oceans, and forests, cycling endlessly through the great natural symphony. Tonight's element, in its silent and humble way, is part of that eternal flow, gently sustaining the heartbeat of existence itself. Think of the wonder we share. This quiet exploration, this peaceful communion with matter. With each soft exhalation, you return the element back into the embrace of the world around you, an invisible yet profound exchange. You are part of this endless rhythm, connected in every silent moment, every restful sigh. Imagine the element we've discovered tonight, existing beyond time, beyond human stories, gently present long before us, and quietly continuing long after. It carries the memory of ancient worlds and dreams of futures yet unseen. You too hold this gentle eternity within each breath. Allow yourself now to float gently, as if carried by the element's invisible hands, toward restful sleep. Feel comforted by knowing that the universe generously shares every atom, every molecule, every peaceful moment with you. Let your eyelids grow heavy, your thoughts softly dissolve like mist at dawn. Know deeply that you belong, gently cradled in the elemental harmony of the cosmos. May your dreams tonight be filled with quiet wonder and peaceful exploration. Rest now, knowing you are safe, cherished, and connected to this gentle element, to this gentle earth, and to the vast, beautiful silence of the universe itself. Good night, and rest peacefully, embraced by the elemental calm of night chemistry.